Hey everyone, welcome to the 394th episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have a lot to talk about today. We're going to be talking about TinyML and a new startup on that front that I think is pretty promising. We're also going to be talking about why we're not seeing more 5G devices for the IoT. The Wall Street Journal's concerned, but we're not. We knew it was going to happen this way. Apple has some new product launches coming up, and we're hearing rumors, including something about an Apple TV 4K. We're also going to be talking about a bunch of Matter updates for devices. So we got a new device from Home Assistant coming. We've got updates for Samsung SmartThings. It's going to be great. We're also going to be talking about new standards for making sure your fitness and activity trackers are actually giving you good biomarkers. This is a new kind of effort from the world of doctors. Verizon has new technology. They're using RF sensing for a smart home security device. And our guest this week is Pete Worden, who is one of the co-creators of the concept of TinyML, also worked on the TensorFlow Lite code at Google. And he now has a new startup called Useful Sensors. And so we're going to be talking about why TinyML matters and why he started this company. Before we hear from Pete, we'll hear from our sponsor, Nordic Semiconductor. So let us kick off the show. But first, a message from another one of our sponsors. This week's sponsor is Firewalla. And today we're talking about the Firewalla Gold Plus. If you have an internet service provider that is offering you speeds that exceed a gigabit per second, you may not actually be getting it. Hardware devices need to keep up, but most don't. And the Firewalla Gold Plus is a 2.5 gigabit per second firewall and router that helps future-proof your home and small business network. Firewalla Gold Plus is equipped with 4 2.5 gigabit per second Ethernet interfaces, 4 gigabytes of RAM, and 5 gigabits of deep packet inspection hardware. Ooh, that's a lot. Basically, it can monitor all your traffic at the speeds you need without your network getting congested. So, to make sure you can operate at future internet speeds, go to firewalla.com/goldplus. Okay, Kevin, let's talk about Useful Sensors. I am super excited about this because Pete Worden, I've talked to him for a while. He was at Google. He was responsible for like the TensorFlow Lite code. So he's been a machine learning guy for a long time. He came to Google from Jetpack when they acquired it. You know how I am about TinyML. The TinyML is machine learning on embedded microcontrollers, like
low power, highly constrained devices. So this is not like things running on your phone or an edge gateway. This is actually running like at the farthest edge of the sensor. And the benefits there's a lot. One, privacy. If you can keep it all the way out there and just deliver insights, you're not sending your data, the actual data to anybody. So that's good, especially for like medical devices or image data. Two, there's actually power savings. Every time you send some data on, you're costing energy. And that's becoming much more important in, today's, I wouldn't call it energy constrained, but we're going to get there. 3, it's fast. You can just get your insights right there. Boom, done. And 4, I feel like there's a 4th. Oh, it's secure. I was going to say price, but okay, secure is good.
Yeah, so that's why you want to think about using TinyML where you can. The challenge is it's really hard to like shrink these algorithms down to something that can run on that edge and do so with, usefulness, right? We've been talking about TinyML for a long time, but the use cases just aren't there. And I'm so frustrated because there's so much promise. So I'm really excited because Pete Worden had left Google a while back and he was starting a company. And now he's coming out of stealth. And his company is called Useful Sensors. They've created a $10 image sensor. So this is a camera that can detect both people, gaze detection, and a limited number of faces. So it's pretty cool. And it's only $10. You can buy it at SparkFun. And it's designed for the maker community because, first off, he wants to get cool ideas, people to try this stuff out. So even if you're like in engineering at a big company, you should check it out because I love some of the ideas they're coming up with. I think something cool is like
stove locks for your stove. You can turn it on parental locks, and that way, if someone who's too short or isn't recognized as one of the household adults comes and tries to turn on the stove, it won't work. So your like toddler can't turn on your stove, which might be handy for people who have gas stoves. I think there's some cool stuff you could do with like refrigerators and other household appliances. Televisions, when I sit in front of a TV, if it actually knows who I am, has a sense of that, it can actually just pull up the show I was last watching. All of these things are really neat, right? And because they focused on privacy, Warden is very concerned about that. They've tried to make it so the device can't actually, anybody who uses this sensor can't get the raw image file off of it. So they only get like, this is person 2, not the picture of person 2. They only get the metadata, right? Not the metadata isn't, it will tell you that person 2 watched 7 hours of TV and maybe they should get up, but it won't give you the picture of you slack-jawed in front of the television, which is maybe nice.
Yeah. So you have those benefits. The fact that this is only $10 is, I think, I wouldn't say it's a game changer because we've seen low, small compute and TinyML chips in the past that, it's about right for the price, but
well, it's more that they've done all the AI stuff for you, right? So you don't have to do any. You just take this and you're like, ooh, look, it's here.
Yeah, absolutely. It doesn't require a lot of power, electrical power. It doesn't require, like, as you said, any of the actual imagery or data to go like up to the cloud to go against machine learning models, churn, and send information back, which would open up, privacy concerns and so on. So, it's a smart approach. I almost feel you're going to disagree with me, and I expect you to. I almost feel it's ahead of its time because the industry at large doesn't seem to be wanting to move this way in a sense.
Yeah. I mean, part of me is like, hey, they don't want to not have all of this data. That's part of it. But
right.
2 is, it is kind of ahead of its time in the sense that like they've been pushing I feel like this could be a stepping stone if it is the right time. But if it's not the right time, then people are going to ignore it. You're right. Because this is a necessary stepping stone to get us into these TinyML use cases. The question is, will anybody decide to take it? I hope they do. All right. We're going to hear more. Pete Warden is actually our guest this week. So we're going to hear a lot more about it from the horse's mouth, or rather from the warden's mouth, as it were. All right. So next up, I couldn't help but pick this up because the Wall Street Journal did this article on super fast 5G gadgets are off to a slow start. And it's all
I'm
about
shocked. No, not at all.
It's all about why we haven't seen more IoT gadgets for 5G since everyone was like, 5G's for IoT. Yay. It's true. We don't see a lot of 5G IoT gadgets, but we can explain why. And it's not like some sort of like failure here. I mean, first off, the hype around 5G was so early. I mean, way too early. We just this last June saw release 17 of the 3GPP standard that basically made 5G viable for industrial and IoT use cases. So it offers things like location services. It offers more control over latency, more scale.
more things on the network.
Yeah, I'm like more. What's the word?
She's moving her hands to, and I'm interpreting what she means.
Kevin's my sign language.
Closed captioning today brought to you by Firewalla.
Exactly. There's basically a lot of stuff in release 17 that everyone was waiting for. So the fact that that just came out in June means that only now are approved devices coming out. And those devices are going to be for the manufacturing, for higher end use cases. And that's because of a couple things. One, it's new. It's cellular. It's going to be expensive. You don't stick cellular in things with, marginal price tags. Two, it's going to require a lot of power.
Yep.
There is a low data rate standard associated with this, which is good, but it's still, the modules are expensive. The power consumption is greater.
What are the current use cases that are screaming for 5G and IoT? I think that's a big part of this as well, because most of the deployments are getting happily by 4G or LoRa or Wi-Fi even.
Yeah, location services, latency is going to be better. And again, the scale should be better. I think a great example, a couple of weeks ago, I went to the John Deere factory and I saw what they were doing. And they have right now an LTE network that they're running because, again, they were waiting for the release 17 to be approved, but they're going to switch that over in probably the next year or so to the 5G network. And the LTE network for them, they were going from like an Ethernet and a Wi-Fi kind of environment. And they hated that. They only stood up the LTE network to trial this kind of out, to learn basically, which is good. And the switch over is going to give them that lower latency that they need, more capacity for more sensors. So that's why they're going to need it. But again, they're literally waiting for devices. Right now, they have like dongles that can plug into things, but they want to see that integrated into equipment. And that makes sense.
Absolutely. And I see why that use case makes sense. I mean, maybe if you have a lot of real-time data that you need to monitor and immediately act upon, say in connected tractors, and by tractors, I don't mean something I ride to, cut my lawn, but
it's actually in the factories. I think you could also see it for fleet telematics, because what'll happen is, it's big data. It like more data will be heading over those pipes, but also there's location services associated with release 17 that are pretty exciting. So I think, again, and for the consumer IoT, I mean, really the biggest advantage, is going to be like fat data pipes. But if you've got fat data, you're going to lose out on the battery front. I mean, when my phone's on 5G, it's a suck fest, right?
I just think what's been mostly deployed up to this point and what's being deployed, and I immediately think sensors, and maybe I shouldn't, but most sensors don't need this. And that's why I'm like, the use cases, I don't know if they're there yet. And granted, the hardware's not there yet too. So maybe the use cases will follow the hardware, sure. But I don't think anybody should be surprised by this.
Yeah, they shouldn't. But again, with that massive hype cycle, I can see why the Wall Street Journal wants to explain this to people. So good for them, I guess.
They want to continue the hype.
Yeah, continue. It's 5G. People will click on it. All right, moving right along. Let's talk about Apple, Kevin.
Right. So Apple, they did not have an event this week, but they did launch some new products. They've updated the standard iPad. No more lightning cable. Yay. That probably has a lot to do with Europe because they have rules now that no more lightning.
Okay. To be clear, the rule is you must use USB-C.
Yes. That's correct. So a lot of Apple things will be changing over. They also came out with an Apple TV 4K, a newer model of that. But before we get into that, because we do have a little bit of interesting information on that, there is also talk about, and it's not the first time we've talked about it or heard about it, of Apple doing something similar to what Google has just recently announced, and that is Google's got this Pixel tablet coming out, but they're going to add an accessory speaker that the tablet connects to, and that basically makes it like a smart home display in a sense, but also you could take the tablet off and use it as a standard consumer tablet any way you want. Apple's planning to do the same thing according to Bloomberg, and I think they would know because it's Mark Gurman writing for Bloomberg, and he seems to know everything. I don't think it'll be quite the same as what Google's doing, though. I wish it would be. And I say this because Apple iPads don't allow something that Android tablets allow, and that is multiple user profiles. When you buy an iPad, it's like buying an iPhone. You are tied to it through your Apple ID, and you are the only one who can administer it and install apps and so on. So with Android tablets, you can have profiles for everybody in your family, and their apps will show up when they sign in. So it'll still be interesting. I think Apple is long overdue with this. I've said this before. They should make a HomePad, which is an iPad for the home, for the smart home, but they don't listen to me, so who knows what they're going to call it. The Apple TV 4K. This is interesting, and I actually found some information in the tech specs of this new device. And sure, there is more HDR functionality and all that, but from a smart home perspective, this includes support for Thread. However, there are two versions of the Apple TV 4K, a Wi-Fi version for $129.99 and a Wi-Fi plus Ethernet version with double the storage for $149.99. I only see Thread support specifically listed in the more expensive model with Ethernet. I don't know why Apple would do that. They don't do it with the HomePod, which doesn't have Ethernet. But if you're thinking about having another HomeKit hub and you want Apple TV 4K to be it, get the more expensive model, at least based on what we know now.
Yes.
And you won't be getting one.
And I won't be getting one. All right. Thank you, Kevin. And in more Matter news, Home Assistant is launching a Sky Connect USB stick that will have Zigbee, Thread, and Matter support. This is really exciting. It is going to be pluggable into. You can plug it your Home Assistant Yellow, which we had been calling Home Assistant Amber, but they changed the name. This should update your Home Assistant stuff to let it talk to Matter devices, which is pretty cool. Yeah.
It is. It's not that expensive. It's actually up for pre-order now for $29.99. I assume you can plug it into, if you're running Home Assistant on a Raspberry Pi or something, that you can still use it. I don't see why not. The software's the same.
Yeah. And they're using the Silicon Labs. They have a pre-certified Matter chip, so they're going to be using that. And it's the first chunk of them is going to ship in November or December. So we are seeing Matter roll out slowly. And speaking of...
more slow rollouts for Matter. I'll just say it. Samsung SmartThings is now Matter certified. Yeah, everybody's coming out with their official I'm Matter certified bits now that the spec is official. But what's interesting is, even though Samsung is no longer in the SmartThings hardware business, they do partner with AOTech, which makes a SmartThings smart home hub. The version 2 hub will get an over-the-air update later this month. So you will have Matter support on your version 2 AOTech hub.
Now, they did say the upgraded hubs will still support Zigbee and Z-Wave, so that doesn't go away. But they won't be Matter bridges. So that means your existing Z-Wave or Zigbee devices aren't going to be able to talk to your Matter devices over the Samsung SmartThings yet.
I assume this is all because Samsung has been a little cagey and said SmartThings will be Matter controllers.
Yeah, because it's going to be a Matter controller. Basically, I've got this hub. When the update comes, I'm going to update. We'll see what I can and can't do. It will become a Thread border router, though. So, now I've got a bunch of border routers in my house. Yay! And you will, too, if you have this and you get that update. So, moving beyond Matter, let's talk about activity trackers, because we have a lot of those and more coming all the time. A lot of options. So one of my favorite organizations out there, it's called DIME. It's the Digital Medicine Society. And it's a group of people involved in the healthcare space and technologists. And what they do is they're trying to make it easy for doctors to understand how accurate and what clinical biomarkers different devices track. So they produce databases for medical professionals that basically say, like, this Fitbit does this and it has FDA approval for this. It has the following sensors. These are proven and these aren't, right? So now they're trying to extend that, because they have it for heart rate monitors. They have it for blood pressure cuffs. They have it for quite a few devices, actually. And now they're doing one for physical activity. So the idea here is they have something called the Playbook. That is their database for all of this information. So they're basically creating a core set of digital measurements for physical activity, and then assessing the quality of those from a medical perspective. And so if you talk to them or go look at this, you'll be able to see what are the best algorithms, who has them. And it's kind of designed for doctors to make decisions about patient care, but it's still really interesting. So we're going to include a link to this in there so you can check this out. As a consumer, it's actually kind of cool because you could be like, oh, maybe I should be using this device because it seems more medically valid. Yeah.
I'm looking at their project partners and their collaborators, and I see a lot of companies I recognize, but in the tech space, I see Fitbit / Google there, but I don't see any of the other usual suspects, which is interesting to me.
Yeah, Fitbit's been involved with them for a while. But yeah, I don't think Apple's because I believe you have to open up your algorithms or at least share some of the creations.
That's not going to happen at Apple now.
So
no.
Yeah, I get it. You know how I'm super high on RF sensing, y'all? I know, y'all do. We'll Well, another project based on RF sensing has launched. Verizon is going to offer its consumers a home security device that uses Wi-Fi sensing from a company called Origin Wireless. They compete with cognitive systems that I know we've talked about on the show. Verizon calls this home awareness. And Kevin, you want to tell us a little bit about it?
Yeah, basically. And it's actually really a software / algorithm update to some of the newer existing Fios routers and extenders. So you don't have to purchase any new hardware, but using the technology from Origin Wireless, the home awareness will detect disruptions in your Wi-Fi signal to see, hey, there's been movement in this room where this extender is or where your router is. And you're going to get that kind of information. It's kind of like a semi-security function, if you will. There will not be any charge for this, at least they say for now. I would not be surprised if somehow in the future they bundle this in and add a fee, but we'll see what happens. But you can turn this on, and without using cameras or other sensors, you can determine if there's movement in your house near the routers and extenders. It's not going to, work 2 rooms away and through walls, I predict. I don't see anything. They're kind of saying, because they even say when you set it up, you kind of want to have your routers and extenders in rooms where you want to detect motion.
Yes. But the benefit is if you run this software, and it has to be, this is one of those things where Wi-Fi has become, along with mesh, that has really kind of destroyed the interoperability of Wi-Fi. With Wi-Fi sensing, any device that's running the Origin software could become another kind of endpoint that can do this. So you could have actually multiple devices throughout your home as long as it's running the right software. That is really compelling. Now, the challenge here is the resolution. So can it just detect motion, or can it detect other things like falls? And right now, Verizon's just talking about motion, but I know that these companies are also working on doing things like big gross motor movements, I guess. So like fall detection is a big one, because it'd be a non-intrusive and cheap way to actually add fall detection to lots of places in your house.
Right. And that hits upon one of the key benefits of without having cameras to detect this type of motion. You have more privacy in the house here. You don't know who's walking around. If everybody's in bed and you get an alert, then, hey, somebody may have broken into the house. That's good enough. You don't need to know who it is. I mean, it'd be nice, I suppose, to tell the police. But Verizon says that there could be a delay of several seconds before activity shows, and that's going to depend on the network's congestion, traffic, and volume. And additionally, you can set the sensitivity level. So, you set it too high and you're just going to get inundated with notifications. But if you want to, you may have to refine it, I guess is what I'm saying.
Yeah. Definitely will need some refinement. And you'll want to turn it on when, if a bunch of people are moving around your house, this is not awesome. And it's not dependent on light. So it's not like a PIR sensor. It's just like, there is a giant bag of salt water moving through my RF field is basically what it's saying.
Does RF not play nice with salt water?
Yes, it does not play nice. It doesn't really go through.
Okay.
Well,
so I'm already trying to think of how I can camouflage myself, but
you could stick a giant bag of salt water, that'd be us, on a Roomba and roll it through and trick it, I guess.
Yeah.
I mean, why though? Why? Okay. Now that we're trying to reverse hack this, that defeats the purpose. No, I guess it would I was going to you could wrap yourself in aluminum foil, but then it would probably detect the disruption. So still a problem.
Yeah. No, that would be like a giant flag. Here I am. I'm in this Faraday cage. You can't see me. Oh, but you can see the hole I've left behind in the network. Oops.
Exactly. Okay. So, I'm not saying that it couldn't be hacked, but we can't figure it out in the 2 minutes that we've devoted to this segment. So
I'm going to work on it, though.
Let's move on to the Internet of Things podcast hotline. This is the segment of the show where we listen to y'all and take your questions. And it is sponsored by Silicon Labs. Works With by Silicon Labs was the go-to developer conference for building the skills needed to create impactful connected devices, including Matter devices. Works With has just wrapped, but you can access all the technical training, keynotes, and expert panels on demand at workswith.scilabs.com. That does include a panel with me, if you just don't get enough of me in your week. I can't imagine that to be the case, but you can call us and ask us your questions at 512-623-7424. And we might answer them on the show. And even if we don't, you will be entered to win this month's prize. And I had said it was going to be a Matter-compatible speaker, but since that's a little slow, I've decided to switch our prize to my old review unit of the Yale second generation lock. This one is going to have the Wi-Fi module in it. So this does not have the Matter module. You can obviously buy it and switch it out. But if you want the Wi-Fi second generation Yale lock, reach out. I'm going to uninstall it and send it out to you. So that is this month's prize. So call us at 512-623-7424. And now let's hear this week's question. It's from the Great White North, aka Canada.
Hi, my name's Alan. I'm calling from Etobicoke, Ontario, Canada. And my question is regarding smart speakers. I have some vacation properties that are widely used by family and friends, and I've not gotten smart speakers for those properties because I operate in an Apple ecosystem with an iPhone and all the Apple devices, but I know others that use those properties use Android devices. So I've always been puzzled as to how I can, put in smart speakers without having to put in both. And now with Matter showing up in some of these devices as part of a Matter ecosystem, I'm wondering whether that is an opportunity for me to make a move in a certain direction. So I'm wondering if you can give me advice. I'm also a SmartThings user, so all of these properties use SmartThings as well. So I'm just kind of wondering what the potential future could be for smart speakers with all of this stuff going on. I'd appreciate the answer. Thank you.
So this is interesting on two fronts to me because I actually do run smart speakers both from HomeKit and Google Home. And if a device actually supports both, I can control them from either one, which is nice. So I'm mentioning that only because you mentioned Matter for obvious reasons, because once Matter is fully rolled out, and if you have Matter certified devices, that kind of resolves any compatibility issues for your guests. It should anyway. But you're trying to help out some Android folks. You've got Samsung SmartThings. So Stacey, you were thinking like adding a Google smart speaker to the mix here.
Yeah, so I thought of this for two reasons. One, going forward with Matter, Google has already teamed up and said they're going to work closely with SmartThings, or maybe SmartThings is working closely with Google, it doesn't matter, to make sure those two controllers, like if they are controllers in your Matter home ecosystem, anytime you add a device, it's going to add to both. So that's going to reduce your complexity. So if you add devices to your homes, your vacation homes with these Google speakers, you could either do it via the Google speaker or the SmartThings thing. And it's basically like you're adding them to the same thing. So that's one. It's going to be just a little bit easier for you. And then two is Google has guest mode. And they have a pretty solid guest mode. I've actually turned it on and played with it. It does limit some things, like you obviously in guest mode can't get someone's personal calendar, but you can do a lot of smart home control things. It's nice.
Yeah, you don't have to really do too much to set this up. Your guests can decide to use the feature or not. All of the smart home controls and history of what they're doing actually doesn't get saved to your account. It gets saved to their own personal account. They can't see your history. You can't see theirs. So it's fairly robust compared to the other solutions.
Yeah, so that's our recommendation for you is an Android speaker, or you could get just the Google Nest Hub second generation, which is $100, and you get like a nice little smart display with your speaker, which I think it's a pretty powerful device. It's got some presence detection in there. I would just get one of those.
Yeah, plus some people don't like to use voice, or they're in somebody else's house and like, well, I wonder what device this is. What's the voice command? If they can see all those devices on the screen, I think that's a better experience for them if you're trying to keep your guests happy.
Yeah, and when it's in guest mode, it doesn't actually record their voices to the cloud. That's another thing. If they're worried about security, like if my mom hates my house because of these things. My mom literally prints out paper maps. So this is how you know she's very serious about this stuff. So being able to reassure your guests that all of their data isn't actually going to Google, even if they talk to this device, is probably kind to them as well. So yay. Mm-hmm. Okay. So
That is our answer for you. Hopefully it helps with your guest setup and reduces your maintenance and ongoing issues. Remember, if you would like to get our input on something, ask us a question, tell us how much you love us, it doesn't matter. You will be entered to win if you call us at 512-623-7424. And that concludes this segment of the show. But please stay tuned for our guest, Pete Worden, who is the CEO and founder of Useful Sensors that we talked about at the top of the hour. We're going to be talking about TinyML, why he made this thing, and hopefully what you can do with it. All of this and more await you, but first, a message from our sponsor. This week's sponsor is Nordic Semiconductor. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is Nordic Semiconductor, and I have Finn Boetius here to talk to us. Hello, Finn. You said you have a specific Wi-Fi use case that you'd like to talk about today?
Hi, Stacy. Yes. Today I want to talk about location services. Nordic has been doing location services for quite a while, and you will be able to get very good accuracy using GPS. And as I mentioned the last time on the podcast, we at Nordic focus on low power wireless. And from that perspective, the main hurdle to overcome when using GPS is power consumption. That can be improved by using AGPS or PGPS, or both. That is assisted or predictive GPS. To do that, we use a cellular connection to the cloud to get useful data. That helps narrow down which satellites are available, their possible carrier frequencies, and results in shorter time to first fix and uses a lot less power than unassisted GPS. If you want to use even less power and only want very rough location, you can use cell-based locationing, which is super fast and very low power, but has an accuracy of about 1,000 meters or 300 when using multiple cells.
Okay, well, got it. Use GPS for high accuracy and cellular for speed and low power. And then you can combine them for assisted and predicted GPS. So where does Wi-Fi come into play here?
Wi-Fi is right in the middle. It uses less power than a GPS-based solution and is accurate to about 20 to 30 meters. So it fills the gap in accuracy and power consumption between GPS and cellular. It is also very useful in areas where you need better accuracy than you can get with cellular, but you don't get a good GPS signal. GPS tends to struggle within buildings or in the middle of the city with big buildings around you. This is exactly where Wi-Fi locationing shines. And when you're outside of the city, somewhere you don't have Wi-Fi around, you usually get very good GPS data.
So I assume some of our listeners might not know how Wi-Fi locationing works. Can you give us a quick explanation?
When you have Wi-Fi around, you can get information from the networks like SSID, signal strength, or frequency, even when you are not connected to those networks. You can use that info to figure out where you are. We work with several suppliers for those coordinates to have the best possible map for our Wi-Fi location services.
Okay, so that is how your new Wi-Fi IC fits into the picture?
Yes, with the NRF 7002 Wi-Fi Companion IC, we now have the whole package. We have the ICs and the cloud services. We have GPS and cellular in our NRF 9160 SIP, and it will be easy to add the NRF 7002 for Wi-Fi. And best of all, everything works in the same SDK.
Excellent. Thanks, Finn. That was really interesting. Where can we go to learn more?
nrfcloud.com. Here you can sign up and test the services for free. That is nrfcloud.com. No spaces.
Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Pete Worden. He is the CEO and co-founder of Useful Sensors. Hello, Pete. How are you today?
Great. Thanks, Stacey. Hi, everyone.
You may be familiar with Pete, who used to work at Google. And Pete, what did you do there?
So I was the TinyML guy. I helped set up TensorFlow Lite Micro, Google's open source machine learning framework aimed at embedded devices. And I got it running together with my team on a whole bunch of really neat little boards. We shipped a bunch of products at Google using it. And I had a lot of fun just putting together all these embedded ML examples.
Awesome. So we talk a lot about TinyML in the newsletter. And here on the show, we don't do it quite as often. But I think it's really worth talking about the difference between like machine learning at the edge and TinyML. And we might even just
as a reminder to everybody, when we talk about machine learning, we're usually talking about two different things, one of two different things. One is training. Almost all of that happens in the cloud. And that is like massive compute. That's where you're shoving a bunch of data at a bunch of computers. And they're like, oh, is this a cat? Is this a word? I don't know. And you build the algorithms based on that. And then you take those algorithms and you put them on a device, or you can still have them in the cloud. And those algorithms, you're going to run data through them. And that part is called inference. And inference is when the algorithm that you trained is looking at your incoming data and says, oh, this is a cat, this is a dog, or whatever it's supposed to do. And so now that we've established that, because it's always worth talking about that, when we talk about machine learning at the edge and the difference between that and TinyML, we're talking mostly about inference.
Yes.
All right. And then what else are we talking about?
A lot of it is really trying to miniaturize what we're doing so that it runs on these tiny, very cheap, very low power devices. Sometimes when we talk about machine learning on the edge, we're talking about running things on phones or smart hubs, in the home. And those tend to have $50 or $100 worth of hardware to be able to run machine learning. So they actually have a lot of horsepower. They have a lot of oomph, but they're also usually sort of mains powered, or they're on things like phones you plug in every day to recharge them. So the promise of TinyML is really that you can run stuff on chips that can be as cheap as, 50 cents, and that you can actually run things that can be battery powered or maybe even energy harvesting powered. And so are able to be in a lot of environments where you don't have people who are plugging them in or recharging them every day.
Yeah. And so making machine learning at the edge or on the device itself and on these constrained low power devices, I like that, without a lot of oomph. What are some of the benefits? Like, why would you want to do this?
So if we're going to get to this world of ambient computing or ubiquitous computing, where there are thousands of devices for each of us, we're going to have to get away from devices that you have to plug in or that you have to recharge yourself personally, because that's just going to be far too many for us to deal with. And that means really trying to figure out ways of building intelligence in that can be battery powered or with energy harvesting. And also, we have to think about privacy. If we've got all of these different devices with microphones or cameras on them, that could be a privacy nightmare. So we really have to think about how we're going to design in safeguards for this to make sure that we don't end up in that dystopia.
So you said if we have all of these devices with microphones and cameras built in, are you meaning that these are devices with cameras built in that talk to the internet? Is that the privacy nightmare, or is it just the cameras and stuff built in?
Yes. And I think that we could end up with, even if they're not connected to the internet, if we don't design them correctly and they aren't checked, and there's no way of people telling how these actually work, I think it's still fundamentally creepy.
Okay. I like that you're trying to avoid creepy. That's always a tough thing. Okay. So we've kind of distinguished like TinyML, what makes it different. We've talked about like how machine learning works. And you've started a company called Useful Sensors. What is the problem that you're trying to solve?
So in one sentence, I want to be able to look at a light switch and say on and have the light come on. Or I want to be able to sit down in front of my TV and have it turn on and show me what I was last watching. There are these very basic ways of communicating with everyday objects around you that I feel like should just work. And they don't work right now. Like, we can't do that. And so a lot of what I've been doing over the last few years has been trying to figure out ways to enable those kinds of what feel to me like very natural interactions.
Okay. And your solution for this has been, hey, I'm going to put an already trained algorithm that's sized correctly for TinyML on a sensor. And your first one of these is able to detect faces. Yes?
Yes, exactly. And maybe a little bit of background as to why we're doing it this way. I've been talking ever since we came up with this TinyML term about this wonderful future where we can, interact really naturally with all these everyday objects around us using voice interfaces, gesture interfaces, having them know when we're around and who we are. But it's been really hard when I've gone to people who make light switches or people who make TVs, and I tell them about all this wonderful open source software that they can use. They usually just kind of look back at me and are like, look, we hardly have any software engineers. We definitely do not have a machine learning team. Can you just give us something that gives us a voice interface? Or can you just give us something that wakes up our TV when somebody sits down in front of it and maybe tells us which member of the family it is? So that's why I left Google. And this is really what we're trying to build with useful sensors.
And it has been a problem. Like, I have been extolling the virtues of TinyML forever, it feels like, because it's fundamentally a very exciting piece of technology to imbue intelligence into everyday devices in a way that doesn't require an internet connection is pretty powerful. And if you have that internet connection, then you can do even more stuff. So I've been super excited, but my excitement has not yet been merited or warranted in the real world. We've seen lots of theoretical stuff and nothing real. I mean, the use case, like one of the first use cases I actually had, like way back in 2015, it was in Netatmo or Netamo. I never can remember how to say it, but it was a camera and it had facial recognition and detection for my family members. And when I left the house and everybody else left the house, it would be like, oh, dude, nobody has passed by me that I recognize in like 15 minutes. I'm going to arm myself. And then it would arm itself and it would send me notifications automatically. I never had to tell it where I was. And it was magic. And to this day, we still don't have that level of magic in most areas of our smart home. And I'm appalled by that. So that was a long way of saying, this feels really necessary. So what's been holding it back for so many use cases?
Yeah, I think there's a big problem with distribution. And I feel like the people who know how to make a lot of these machine learning models and algorithms are not working in industries where they can actually build this into everyday devices. And the people in industries who build everyday devices don't have the time and the resources and the ML knowledge to actually take this stuff that's kind of available as open source, but still requires a bit of a research project to actually turn into an end-to-end system.
So, your goal here is to create this end-to-end system. So what is it specifically that Useful Sensors is going to deliver to customers?
So if we had video, I'd hold up this little 20 millimeter by 20 millimeter board, which has a small microcontroller on one side and a tiny camera on the other. But from the system builder's point of view, all you really have to know is it's got one pin that goes high when there are people nearby, and then an I2C interface, a very standard peripheral interface that tells you how many people are there, where their faces are in the viewfinder, tells you if they're actually looking at the device or not, and also does some simple facial recognition. So it can tell you sort of, hey, this is person 7, this is person 3. And we're putting that up on SparkFun for $10.
That's great. So now if I'm a developer, maybe I'm developing a refrigerator and I want to let my parents set a lock after a certain time on the fridge door being opened. This sounds like a horrible thing to do as a parent, but you could actually implement something like that. In the fridge door, use just $10 sensor. And it'd be like, oh, it's after 10 o'clock. I'll open for adults in the household. Or my liquor cabinet. This is way better than hurting my kids. Okay, this is better than like starving my children after a certain time period. That's terrible. Don't do that. Okay, so I like this. And is the idea here, like I can think industrial use cases, they would love to be able to, like in certain areas of their factories, they would love to be able to not have people in them. And if you see a person, you want to set up an alarm. And this could be a great way to do that. Your goal, since you're selling it on SparkFun, this is probably for DIYers, developers at first?
Yeah, exactly. I really have found the maker community to be an incredible source of ideas and inspiration and creativity and imagination. So I'm not expecting that we're going to make any money really selling these things to developers, to these independent developers. But a lot of what we're trying to do is just kind of start manufacturers of everyday objects imagining what they can do with this stuff, because this is such a new idea that they aren't necessarily even aware that this is possible. And the maker community is like fantastic at taking these sorts of components and building really compelling things with them. Like, some examples, we're coming out with some project guides on Hackster, and, people have been building things like, hey, a fan that actually follows you around the room as you move around.
Like an oscillating fan that's like, ooh, here's a face, I'm going to blow on it.
Yes, exactly.
And then, so you're going to start with the sensor. What other areas are ripe for this sort of, I guess it's consolidation in the sense that you're doing the algorithm plus the sensor plus the microcontroller all in one little board?
One area that we're seeing a lot of interest in from manufacturers is actually around gestures. So hand gestures, swiping left to move to your next slides on your laptop, putting your finger to your lips to mute your TV, putting your hand up to pause. That seems like it's something that we've had a lot of requests for, and we're hoping to bring out a follow-up to the person sensor to have a gesture sensor that works in very much the same way very soon.
In a similar price range?
Yes.
Okay, so the people detection sensor is available now?
Yes.
And gesture soon, and on SparkFun. Okay, this is a company, so you planned, this is a money-making endeavor at some point, or what's kind of the business goal for Useful Sensors?
So the business goal is really to get enterprise customers. So those manufacturers that I'm talking about who build appliances and TV.
Liquor cabinets.
Yes, liquor cabinets. And the liquor cabinet example is interesting because we've actually had an appliance manufacturer who wants to put parental locks on stoves.
That's a good idea.
Yeah. And so selling these, like, we would love to have the people who make these everyday objects buying these modules off the shelf, adding smarts to their devices. We sometimes call it the IoT without the I, because we're actually trying to make things intelligent without requiring that always on internet connection.
Now, I've seen devices like this. So the big chip manufacturers, I feel like I saw one of these as early as like 2014 or 2015 at CES. Qualcomm had something that was pretty sweet. And I was like, oh my gosh.
Yes.
So how is what you're offering different than maybe what some of the bigger companies might be offering?
So we haven't seen that many companies offering complete end-to-end solutions. A lot of companies are offering tooling and components, and it often feels like you're being handed a box of Lego bricks and the instructions and being expected to put it together yourself. Really, what we're hoping we're doing is different, is that we're handing people who don't necessarily care what's happening under the hood something that just works.
Awesome. And then how do you deal with things like drift? Because no algorithm stays the same forever, but in your case, it feels like it might.
Yeah. One of our sort of things we're betting on is that people's faces don't change that much. But the counterexample to that is like, 2020 when everybody started wearing masks. So there's definitely some challenges there around, like you say, drift, things changing over time. We're hoping a lot of what we're focused on in terms of hand gestures, human interface things, speech recognition will not change radically over, maybe the 10, 15-year lifespan of one of these everyday objects.
I imagine my face will change in 15 years, but it'll only get better. All right. So one of the things you mentioned is that we're going to be sticking these tiny little sensors everywhere, not just your tiny little sensor, but in general, tiny cameras, tiny mics. They're in all kinds of devices, and a lot of them talk to the internet. So having local machine learning is kind of awesome because your personal data hopefully doesn't go out, only the insight does. How are you thinking about privacy as we shrink these further and then make them super local?
So one of the things that's very much been on my mind is I see this future coming where there are a lot more microphones and cameras around us because they're useful. But I really want to make sure that we're able to check and verify that they are not spying on us, and trying to think about ways to build in privacy by design. And also, one of the things I kept hearing at Google was, hey, is Google spying on my conversations? Because people would be talking about, Tunisia, with their friends, and then they'd see an ad for a holiday in Tunisia, and they'd be like, what the hell? And I was always able to tell them, like, hand on my heart, no, Google is not spying on you, because I've worked on that code. I know, we just don't have room, if nothing else. But I could never prove it. And so what I'm really hoping we can do with this way of designing sensors is being able to make it so that third parties like Underwriters Laboratory or Consumer Reports can actually take the hardware, verify that there's no connection between the microphone and the camera and the outside world, and actually give people some confidence that, like you say, only the insights are coming out of this sensor. Only the fact that somebody is sitting down in front of the TV or doing a gesture, that's the only information that you can extract. Even if the rest of the system is hacked, you can't get access to the raw video or audio feeds.
So like a privacy mark that is enforced by some third party, neutral third party.
Exactly. That can be checked by whoever wants to check it, basically.
It's like, that's going to add costs to your $10 sensor.
Yes. I mean, I'm hoping that it will actually add enough value to consumers that my hope is that people will be willing to pay a little bit more to have something that they can trust.
I want to say that they will, but they probably won't. So I feel like the result here is going to be that we have some sort of standard that mandates it, or a government regulation that mandates it, because otherwise your device will be more expensive. Yes, it will be transparent about what it does, but someone will come in without that transparency mark and they will undercut you on price, and consumers would rather not think about things like privacy and just focus on price. It's just sad.
You may well be right, but I'm hoping not.
Well, yeah, I hope I'm wrong too. Keep pushing. All right. Thank you so much, Pete.
Thank you so much, Stacey.
And that concludes this week's episode of the Internet of Things podcast. Please join us next Thursday, and don't forget to subscribe. And if you can't get enough IoT news, I would love for you to sign up at www.staceyoniot.com for our weekly IoT newsletter, where we explain all kinds of things that we don't even get to on the show. Once again, thank you for listening, and please subscribe.